Good afternoon, ladies. Can I see some ladies? Yes, they are, great. And the gentlemen. I hope that you had a good lunch and a lot of coffee, because you're not supposed to get asleep today. But I'll do my best that it doesn't happen. My name is Mina, and I have two last names, Boström and Nakićenović. One is Swedish, one is Serbian. Which one is worse, which is better, I will not tell you. I have been working with software development for more than 15 years. I have been working with different platforms within different areas with different programming languages. During the latest 10 years, I have been developing trading high-performance systems, financial systems, mostly implementing them in C++, if I dare to say, because I know that most of you are Java developers. But today, I'm going to talk more about Java platform than C++, not because worse is better, but you're going to see why. At home, it's me, and at home, I take care about 3 small boys. It's my children. And I also take care about 1 big boy. It's my husband. And why do I mention him today? You know, because it's his fault, as usual. It's his fault that I'm here today. Or maybe I should put it another way. It's thanks to him that I'm standing here today and giving this talk. Why? Now we have to go back to the year 2001. We worked at the same company, and as soon as I met him, I realized that he was really very passionate about software development. I was too. And I thought maybe when we talk about software development, I should mention some of those important books that I'm reading during my spare time. At that time, it was Design Patterns, very hot book. But all of a sudden, he asked me, what do you think about these 12 principles? And I was a little bit surprised, because nothing was related to 12. I knew Gang of 4 and etc., but 12 principles? And then he said, oh, haven't you read the Agile Manifesto? And you know, it was summer 2001, and the Agile Manifesto was published in winter 2001. So I didn't have a time to read that. But of course, as soon as I came back home, I read the Agile Manifesto. And I really like what I read. Some of those principles were coming from extreme programming, so some of those I recognize. Some of those were new for me. But I have started implementing some of those principles. And after several years, I realized that if I apply such agile principles when I'm creating a software architecture, then I achieve to get lightweight solutions implemented within the given time frame and within the given budget. And then after several years, I thought, maybe I should publish a paper about that, about my industrial experience regarding that. And then I wrote the paper. Here is my paper. And I sent to one journal in order to get it published. And I was sitting at home and waiting for the reviewers' comments. And after maybe 1 month, I got feedback for my paper, and it was very good. They liked my paper. And they said, we are going to publish, but, you know, there is always one but. You have to remove the reference number 13. It's not a scientific reference. And since I wanted badly to publish my paper, I removed that reference and got my paper published. But I felt a little bit sorry about that, because it was one of my favorite references. And at that time, I promised myself, one day I'm going to make a presentation that is based on this reference. And that day came today, so I am giving this talk that is based on this reference, an article written by Richard Gabriel, Worse is Better. Richard Gabriel, he's a guy who has been involved in software development in many, many, many years. He is both a developer and a poet. So you can visit his website, Dream Songs. So he's publishing both software development articles and his poets, and his poems. And then it was year 1990 when he published his paper, Worse is Better. He said it was like a spontaneous lunch. He was outside the office. He was talking to some other guy developer. And at that time, it was like 1990, they were talking, he was working a lot of Lisp. And all of a sudden, another person asked him, oh, what do you think? Why people like C more than Lisp? And then Richard Gabriel said, oh, because worse is better, ha ha ha. And he laughed. But when he came back to office, then he thought, oh, I got an idea for a new article. And then he published the article, Worse is Better, about describing some solutions that are more maybe technically worse, but they're better in practice, can be applicable. 1 year after that, he changed his mind. So he published a new paper that is called Worse is Better is Worse, in fact. It was in 1991. A year after that, he published a new article that is called Is Worse Really Better? And then he continued writing articles. In the year 2000, it came a new article, Back to the Future, Is Worse Still Better? And the last one for the same series is the Back to the Future, Worse Still is Better. I really recommend reading these articles. They're those feeling good articles when you read them, and you can learn a lot of things. But why did I like those articles? Because all of a sudden, I felt like they're telling my life story, my experience in software development, especially within one area that is going to be presented today. It's a model-driven development. Now you're going to hear my model-driven development story and why I got inspired by Richard Gabriel and his articles. We are going back to the year 2001. I got a job at one new company. It was a relatively small company. And as soon as I started working there, they said, oh, you know, we have a very advanced architecture. Everything is model-driven. You don't have to do anything, just to do some programming in JavaScript. And I was wondering, like, I'm going to have a very high salary just for do some programming in JavaScript. Can it be true? But we will see. But then they said, do you know what is model-driven development concept? You have one or several models, then, and you are using them to describe your business solution, and usually it's on a very high abstraction level, so you don't want to go in some specification and details how to implement that. Maybe you can have a meta model which describes those models. Usually UML is used for modeling. Then from these models that are on the high level of abstraction, you do some transformations and transform these models to platform-independent models and platform-specific models. Platform-independent models are on a little bit less level of abstraction with some implementation details, but they are not platform-specific. And then platform-specific models, they're really platform-specific. And then when you transform your models and put some more implementation details that are coming separately from some place, then you have the generators and you generate the code. So the whole idea with the model-driven development, or how it is proposed by OMG Group and MDA concept, is that you model once, you model your solution, and press the button, and everything is generated. If you want to change something, you change that in the model, just in one place, and then everything is magically generated, and everything happens. So we will take a look at the architecture that they had at that time. So you still have to think that it was year 2001. They have one model that was called the entity layer model. They used XMI for describing that within a UML profile, and it was described all entities in the system. From that, we generated the SQL and database schema, and the database was also generated from that model. So we have every time when we have to change something in our system, we just change the model, and then the database schema was generated in the database. This entity layer model was used by another model that was called the business object model that was saved in an XML format. Each object in a business object layer, it was in fact one SQL statement from the entity layer model, one SQL query, one select. So in that way, we built our business objects. And they were sent as XML trees to the next layer, that was application object layer, which consisted of those business objects, and then we implemented methods for those objects. And then above that, it was interaction layer, and on the top of was user interface layer. Also, the goal was that you then could choose if you want to have a HTML user, front-end user, or mobile application. And how it was implemented. So the framework worked that you were supposed just to program in JavaScript to describe those objects within the application object layer. They were Java beans executed on JBoss. Within the interaction layer, we have servlets executed on a Tomcat web server. And then on the top, we had XSL transformations that read those XML trees and converted them to the wanted output, HTML or something else. So when I saw this architecture, it was like, oh, wow, it's really so advanced and so good. It's like, I felt like, oh, all those smart people that came up with such a great solution. And now we'll see. And we can summarize what happened with that company. First, we have a 6 layers architecture, very good separation of concerns. So each layer was separated. It was only XML objects that were sending between the layers. We have a model-driven development plus separation of concerns. And we thought that we built something that is called a build for change, that is easy to change the layer or implementation. It doesn't depend on the platform, and etc. So we thought that we applied that agile principle, embrace change. We used very sophisticated tools and very sophisticated models because we thought if we do that in a very general way, very flexible, it's going to be attractive for many customers. So, simplicity, the whole point is that when you have your framework ready, you should just program a little bit in JavaScript and you can program all features and that you want to achieve with your framework. We were also concentrated on that testing. So within each layer, we wrote a lot of unit tests. So it was almost 100% unit test coverage within each layer. And we did a lot of pair programming that was very good, that we could really faster develop our application. The only thing that maybe we did that too much because I and my husband, we did a lot of pair programming, and now we got married and got 3 kids, so maybe you should be careful a little bit. But it's a good idea to do pair programming anyway. But with such a system, it was very complicated to implement even simple functions or queries. It was such a complex framework. So even for simple selects or simple things that you want to do, it was a lot of work that needed to be done. Framework was never stable enough. All the time, it was some simple things that you should add, and so it was very unstable. Framework developers were separated from the application developers. They thought it would be the best. Framework developers developed the framework, and the application developers are sitting and waiting for the release from the framework team in order to build the applications. And unfortunately, we didn't get any customer. In fact, it was a really very bad point of time. It was year 2001 in Sweden. IT crisis had started, and it was really no money on the market. And we found only one test field customer. He didn't pay, of course. And he used our complex framework to write a very simple application. And when you don't have a customer, what do? Then you're sitting and developing your system much more, and you're trying to think from the customer perspective. Oh, maybe they are going to need this feature, maybe they're going to use this feature, and etc. Unfortunately, this company got bankrupt because we didn't have any customers, we didn't have any sponsors. And I thought, oh, it's a really pity. It was such a good architecture, such advanced system, and we didn't find any customer. But it was like what happened. So I've changed the job. And then after some time, I started working for another company. It was year 2003. And they were developing financial trading systems. And when I took a look at their architecture, it was almost what I have seen before, although it was a little bit more simple than the 6 layers architecture. So they didn't generate the database schema. They had a database that was a Microsoft SQL, but business object layer was described by business object model that was in XML format. And then they had an application object layer and then user interface layer. And all objects that were passed between layers were XML trees. And it was also, for application server, JBoss was used. And they thought, oh, this time it's going to be a successful company because they have a similar architecture that the company before, but they made it more simpler, so it's going to be good. But if we summarize what happened, so they have a 3 layers architecture, so it's still very good separation of concern. Model-driven architecture plus separation of concern built for change. So you recognize the same things as we had in the previous company, although it was completely different people working there. But it was the same conclusions that we came. It was still very complicated to implement even simple functions or queries. Framework was never stable enough. Framework developer worked separated from application developer, all the same things, although it was a different company. And we didn't have a customer. So we were building our framework for 2 years without any customer. We had one big company who was a sponsor, but after 2 years they said, now we have to close the project because there is no customers who are going to use that. And after that, I did the following solution. Model-driven development. It cannot succeed. Why? It assumes such a big upfront design that you model, and then you do some other things based on your model. Starting curve is usually too long. It takes too long time before you can go in production with your model-driven development system and get some return of investment. It always becomes too complex and cannot be stable. And then model-driven idea. Theoretically good, inapplicable in practice. Now it's my favorite citation. The difference between theory and practice is much greater in practice than in theory. So I thought all thoughts that they had about the model-driven development, it's very nice, but it's theoretical. When you start applying that in practice, it doesn't work. And then I promised to myself, model-driven development, never again. And then I started working for my current company. I have been working there for 10 years. It's a very big, successful company. We have a lot of customers all over the world. So we develop financial systems. So we have 25,000 customers across the 70 countries. Our system that we are developing is called Front Arena system. And it's responsible for order management and deal capture on electronic exchanges. And the market access is based on the client-server architecture. It's a picture about all our components, and all of them are using something that is called Transaction Network Protocol. It's an internally developed financial message protocol for transaction handling. It's based on the TCP/IP, and it's used by all our components in the system, and they're sending a message between each other in that way. And as I said, at the beginning, we had just C++ components. And that's why the TMP message definition, so definition for those TMP messages were placed in C++ header files. But during the time, we developed some components in Java, in C#. We have two different platforms, Windows, Linux. And all of a sudden, it became very painful to work with the C++ header files for TMP message definition. So we could say that there were some problems with the TMP message definition architecture. Components that use the TMP protocol, they're implemented in different programming languages, and they have to use the same message definition, of course, because all of them are using the same message protocol. The same definition is defined in different C++ files, and furthermore, we had also some duplication of the information in those files, so it wasn't they weren't defined in a very nice way. And such architecture had some critical problems: unnecessary duplication of data, and also programming language dependency. So we thought we should introduce some new architecture for the TMP message model, for the TMP message definition. Also, it's important to mention, here's just one picture how those messages are hierarchically structured. Currently, we have more than 1,000 messages, and they are updated on a daily basis. It means that all developers, regardless if they are C++ or Java or C# developers, they're using those C++ header files and update the message definition almost on a daily basis. And you can imagine, as a Java developer, is it a nice feeling to open a C++ header file and change something there? Probably not. So we said, okay, we are going to apply attribute-driven design in order to produce the new architecture. We could define some quality attributes. The new architecture should be easy to modify because people are doing that on a daily basis. It should be easy to use, not nice to have a C++ header files. It should work for all different components implemented on different platforms and in the different programming languages. It should be reusable, and it should be very efficient to use. And then we defined 4 architectural drivers: centralization, data consistency, programming language independency, and presentation. And then we ended up in the situation, now we have to make some architectural decisions. How our new architecture is going to be. And all of a sudden, it was like, model-driven development is most suitable for our new architecture. But haven't I said model-driven development never again? So what do you do in such situation? You start screaming, ah, like what you are supposed to do. You know that it wouldn't work, but you feel like it's the right way to go. And then, first, at that time, I was starting thinking, okay, all those failed model-driven architectures, maybe they didn't fail because they were model-driven. Maybe we did something else that was wrong. And I was trying to summarize everything that we did and why it failed. First, starting curve was too long. We were developing for like 2 years, and we never achieved to go in production. And it happens twice in 2 different companies. We had a lot of waste in our system. We built a complex architectures, although we did not know if all parts are going to be used, honestly. We built a lot of things for future. We planned, oh, maybe this customer is going to use this, or maybe this customer is going to use this. And we were so focused to create a perfect solution that covers all scenarios, all possible things. We never got to know if we built the right product, because we never had the customers to confirm that it's exactly what we want or not. Also, it's questionable if we built the product in the right way, because our frameworks were unstable all the time, so maybe we didn't build them in the right way. And then I was thinking about something else also at that time. First, I was trying to summarize everything that failed before, and also what is the main point with the software architecture? What is the definition of software architecture? Now you have 3 different definitions. All of them are proposed by the famous people from software development. Now you will have 1 or 2 minutes to think which one is chosen by the International Association of Software Architects. What do they think? It's then International Association, IASA. Maybe some of you are members of that. What did they choose as the most valid definition for the software architecture? Now we have 1 minute to read all 3 definitions and to vote for some of them. So, who is going to vote for the number 1? Nobody? Oh, there is some. 1 vote, I saw. For the number 2? Many votes. Number 3? Okay. So I said, I mean, everything is relative. It's all valid definitions. But it is definition number 2 that IASA has chosen as the most valid nowadays. That software architecture is the art and science of designing and delivering valuable technological strategy. And that was the point, what we didn't do before. We didn't create value with our architectures. We didn't do that. We didn't have a customer, and we never created any value with all advanced things that we did. And then I was thinking, maybe model-driven development can be agile in some way, because I was happy with the application of agile principles within the different areas. Model-driven development concept is such a big concept, but maybe it could be simplified by the application of agile principles. Someone told me, oh no, it's a bad idea. I mean, it's such an upfront design. How can it be agile? It can never be agile. And then I was starting to thinking, okay, what is the heart of the model-driven development? It's accelerated development that is achieved by the centralized architecture. As I said, Johan, the heart of the model-driven, it's a set of models. You change something there, and then you generate everywhere. And then also separation of concerns, both on technological and business aspect. And in that way, you make your system architecture more flexible for the future changes. What are the main goals of Agile and Lean principles? To develop qualitative and cost-effective solution and deliver them quickly. You don't want that it costs too much and that you want to deliver them quickly. Welcome changing requirements, even late in the project. So if someone has changed his mind, you should not tell him, oh no, it's too late, you should wait 6 months for the next release. You should be able to put it in some way in your architecture or product. To deliver business value, to eliminate all possible waste that you have in your system, and see the whole picture that you have. And you can see that both model-driven development and Agile and Lean principles, in fact, address the same goals. Making system less sensitive for the future, from the frequent changes, accelerated development, and eliminating waste. So now we are going back to our architecture. What do we have now? We have definition files that are defined in a C++ format. One day, we would like to get model-driven, that we have a maybe platform-independent model with all definitions. Then to have some transformations which transform from that model to platform-specific model using some implementation details, to have code generators, and then to define TMP message definition in different programming languages, in C++, in Java, in C#. And of course, since we already have some data in the definition files, we have to do the reverse engineering to put all data in the model that we are going to define. And then I was trying to think in agile way. Okay, it's a general picture, how it should look like. But in our situation, simplicity is essential. Can we simplify that in that way, in some way. Eliminate waste. It's nice to have a platform-independent model and platform-specific model and do a nice separation of concerns. But maybe it's not needed in all cases. Maybe it's too much to have two different types of models if you don't need them really. And don't build for tomorrow. That we did previously, that we build such advanced architectures, although we didn't know if someone is going to use or not. So by using those three principles, we came to the solution. We are not going to have a separate platform-independent model and a platform-specific model. We are going to have just one model with all our information, even some C++ specific information that we currently have in C++ files. Okay, it's good enough. Model is not going to have such a nice separation of concern, but on the other side, we are going to maintain just one model instead of two models, and we are going to skip all those things in that model-driven development picture. Then we were thinking about organizational maturity. No one, or officially, we were not using UML models or some advanced tools for modeling. And we were thinking, okay, usually model-driven development proposes that you use UML modeling, but in our case, developers are not used with that. Maybe we can use just a simple XML format to define our model. And we thought, okay, XML format is good enough. We lose the abstraction benefits of UML, but on the other hand, we get a simplicity to work with the XML model, and people are familiar with that. And then we were thinking about the code generators. Okay, now we defined we are going to have just one model. It will have a XML format, but now we have to implement somehow code generators that are going to generate the code in different programming languages. If we have different teams, C++ programmers, Java programmers, C# programmers, which language should we choose? Okay, if we have a model in an XML format, maybe we could use just a simple XSL transformations as a code generators. It worked fine. So when we applied all those Agile and Lean principles and removed some stuff, what did we get? We got perfection. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. It was Antoine de Saint-Exupéry that said that, but I really think in most cases we can apply his sentence. Because usually you think the system is going to be perfect if I think about all details, if I add all details. But in some cases, it's completely vice versa. There is another guy, he is a very dedicated C++ programmer, James Complin, who said, simple does not mean simplistic. We are not going to take away features that we need. We are going to just simplify things to the certain level that it's simple enough. But of course, some important things are not going to be taken away from that. So it was how we defined what we are going to have in our model-driven development architecture. But the other question was how to produce such architecture. On one side, we have a definition files, and we have to do reverse engineering from them to collect all data, to put all those data in the model, and then to implement code generators. In which way we are going to work? Where should we start? What do you think? Should we model first? It's, I could say, the most usual way when you work with the model-driven development. You think, oh, first I'm going to define my nice model to think about everything, and then I can do the rest, just put the data that I have and do code generators. But there is one very big risk if you start with the modeling. There is a risk that you specify things that are never going to be used, because it's our nature. Maybe it's the problem that a lot of us that are developers, we are mathematicians in our hearts, and we want to define everything nice to cover all cases. So it's a little bit dangerous to start with a model, because you want to create a nice and very general model, but in that way, you introduce the ways. Maybe you introduce some features that are never going to be used. Should we start with reversing the existing data? Yes, but we have to have a model definition in some way. We can extract the data, but we have to put them in the model. So we cannot work without modeling at all. Should we do first forward engineering or to implement code generators? Yes, but we cannot implement them if we don't have a model. We have to read from the model. And then I was thinking about Agile principle, deliver working software frequently. It would be nice to get some working version that covers all those three parts in a quick way. And that's why we made the following decision. We work according to sprints, and we will set one spike, one scenario that goes through the whole round-trip engineering, all three parts of our model-driven development. What does it mean? So we start the first sprint or the first spike, reverse some data, not all, but take some of the data from the definition files. Put them in the model and design just that part of the model for that reversed data. Implement code generators for these data that you have in the model. And then, when you have generated the code, compare with the definition files to see if you forgot something on that way while you were doing. And then, adjust and refactor. But all the time, do all three parts together so that you can have, at least for some certain data, the completed functionality through the model-driven development. The thing how we develop our architecture, it reminds us of something that Eric Ries proposed with the lean startup methodology. It's called the build, measure, learn loop. He said, build the feature, measure whatever, if it delivers some value or not, learn from the result, and enter the new loop. So you should always work with a build, measure, learn loop. So you build something, you measure if it creates value and what value it creates, and then you learn from your experience and start the new loop with the new knowledge. What is the thing that you are building within that build, measure, learn loop? It's something that is called the minimum viable product. Here's the definition of MVP. It's a version of a new product which allows a team to collect the maximum amount of validated learning about customer with the least effort. It means you create some product, just that it covers some functionality. It doesn't have to be perfect. It should be vice versa. And send it to the customer, that he validates, okay, it is something that I want to get or not. And then after then, you can decide, okay, I will continue building in that way, or I will switch. Also, Eric Ries called those pivot or preserve. So after each build, measure, learn loop, you should decide, should I preserve that way of building product or pivot? Should I change the direction? So, okay, our product was our architecture was in internal. We didn't have customers for that, but it was developer who verified it was the good way how we built that. So now we can go back to our famous Richard Gabriel, what he said in 1989. And you realize that it's similar to the MVP concept. The concept known as worse is better holds that in software making, it is better to start with a minimal creation and grow it as needed. I know that most of you think, okay, it's natural, but it's not natural when it comes to the implementation. We don't do that in that way, always. So, application of Agile and Lean principles in model-driven development. We modeled just what we needed according to the input from the definition files. So when we did the reverse engineering, we just modeled that part of the model for this data. So in that way, our model was pulled by the request. So we model just the data that we have. We don't model some data that we don't have in our definition file, and maybe we'll have in 5 or 10 years, or we'll never have maybe. And also, we eliminated that potential introduction of waste. We generalized model only for the repeating artifacts. So we had a rule. If something appears just once, just put it in the model in some way, text box or some, you don't care about that. But next time, when you get the same type of data, then you can make a nice part of that model. But don't spend time for things that occurs just once, because it's not worth the effort. Just put them in the model, that you can generate them. So after each spike round trip, we learned a lot, and we knew how to proceed, how to continue with the next spike and next sprint. So we could see early in the project which parts of the model-driven development had to be improved. Because from the beginning, we implemented all three parts, so we could really easily see where we did the right things, where we did the bad things. And when we develop model-driven in that way, we shortened the starting curve, because we didn't do modeling in 2 years and building something that it didn't work. We could produce a working piece of software after each sprint, and we just let it grow. So, how our model looked like? It was very ugly. We had some C++ memory location definitions that we had then definition files that we had to put then in the model. And we put them. For example, here you have a C++ memory location. And someone told me, oh, you merged the platform-independent model and platform-specific model. It's an architectural error. You cannot do that. I thought, okay, I can do that, because then I have just one model to maintain. Okay, it's not nice to have a C++ memory location in your model, but it saves time for you. We got one model that is very easy to maintain. And of course, I was a little bit proud of that implementation. It was my idea and so on. So for all new employees, I was showing like our model and how it works nowadays. And some of them asked me, oh, do you call it for a model? It's such an ugly model. And then I was almost like starting crying. But then I thought what Eric Ries said about the MVP concept. He said, first time when he applied that idea, build, measure, learn, and to build then a minimum viable product, he was really ashamed to show it to his family. He said, oh, I cannot show to anyone such a full product, that is such an ugly product. But then he said an additional thing. Yes, maybe it wasn't a nice piece of software, but we used that to get a feedback from the customer. So we knew how we should produce in the future, how we should proceed in the future, and how we should build our model after that. So after several build measure loops that we applied, we could conclude the following. When we finished with the reverse engineering, we could release the new architecture and deploy it to production. So we didn't have any time because we tested all the way in each sprint, so we didn't have to do some special additional tests. As soon as the developers stopped wasting time on the manually updates in the old architecture, we were starting receiving the return of investment. We got a lot of time because now we have a model-driven architecture. Updates, everything is generated automatically, so we don't have to spend time on manual updates. We got working architecture which creates a business value. We got an ugly but good enough model which creates a value. And now we are still constantly improving it. But now it's no danger to improve it because we are all the time receiving the return of investments. So we don't have to get stressed, oh, you should finish that within 1 year or 2 years, and so on. So what do you think? Why did we succeed the third time? By accident? Third time lucky? Because worse is better. We succeed because we adopted or accepted, decided to implement something that is called good enough solution. It is proposed by Scott Ambler. He's writing a lot about the agile modeling, and he says that good enough solution, they are practices based, and then he has an extended definition about the just barely good enough solutions. The whole idea is that such solutions are situational, like in your situation, it is the best solution. Maybe for some other company and some other situation and some other system, it won't be the best solution. So you see on that diagram, you have an effort and value that you receive. Usually, when you start building your architecture or your system, you are investing some effort, and then the value is rising. But at one point in time, you are investing more and more effort, but the value that you receive, it doesn't cover the effort that you invested, because you are investing too much effort compared to what you receive. So you have to catch the top of that curve, and this solution is good enough. Okay, each solution can be better, of course, but it's a question, should it be? Should it create, is then going to create more value or not? Probably not. So the thing that we did, we find a good enough solution for our situation. So here I will show one example with a Hello World program, and what is a good enough solution. If you ask different people to write a Hello World program, for example, someone who is attending like junior high, he'll write like this. Someone who has studied software development or a student are going to write a little bit more advanced solution for the same thing, Hello World. Someone who has been working with the software development maybe in 2-3 years are going to write such a Hello World program. And someone, senior developer, is going to write the program like this for the same functionality. And now this is the question. Which one creates the value? Which one is good enough solution? Of course, the first one, in our situation, I mean, it's enough. You don't have to have advanced solutions. Is worse better? What do you think? We can ask Richard Gabriel, who wrote all his articles about that. He said, I still can't decide. So he's still publishing every second year, I mean, with the different opinions. I mean, it's a relative question, of course. It's difficult to decide. What I'm going to say, it is often, since worse solution usually create a bigger business value. What you receive, it's my opinion. And now, it should be time for questions, but I will do that vice versa. I will ask a question so that you are going to answer me. What do you think? Is worse better? Or, of course, you can ask me questions. Is there any questions? No? Maybe you, oh, okay, there is one.
I'm interested in how many messages in this process of reconstruction, this whole system of communication, have you discovered to be unnecessary and maybe removed? Were there any, or have you discovered that, for example, 5% were generally unused?
Yes. We discovered a lot of them, of course. It was, I think, 15% that were not used. So it was a really good way to clean up, because we put them in the model, but in a separate place in the model, just like a text box in the model. So it was really a good way during the reverse engineering that we discovered that we had a lot of waste also in that system. And it's also the point. Usually you have a lot of waste, but you are afraid to remove things. So if It is the answer on your question. Maybe several minutes are not enough for you to think about is worse better.
It's not much questions, more a comment on removing stuff. I usually define good developers as the developers who add value and remove code.
Okay. Okay, it can be done in that way. But you should think it's a task for you to think about is worse really better or not, and we can talk on the corridor and vice versa. And I have my last slide that I left for the end about the presentation evaluation. You're going to evaluate my presentation. But don't forget that the presentation doesn't have to be perfect because just barely good solutions creates usually the biggest value. So your task is to evaluate if it was good enough or not. Thank you for your time.